In this video, we're going to discuss writing equations for word problems in standard form. Now, I want to let you know that this is very different than writing an equation in slope-intercept form, and I will explain why. We can still use the four-step process, although it's a lot more straightforward. So step one, as we know, is find your question. So what do they want us to do in this problem? Well, all they want us to do right now is to write a linear equation that models the possible amounts of large birdhouses, X, and small birdhouses, Y, that Nyla can build. Okay? So we know that X is going to equal large birdhouses. And Y is going to equal small birdhouses. Okay? So if we're going to go to step two, they're going to give us information. We're looking for what they give us. So what they give us are that Nyla has 80 feet of wood total. And that when she's building birdhouses, it takes 8 feet for a large and 4 feet for a small. Okay? So when you're looking at a problem that is worded like this, where the units of the things you are comparing are exactly the same. She has 80 feet of wood. It takes 8 feet to make one large birdhouse. It takes 4 feet to make a small birdhouse. All of these units are the same. That should clue you in that you are writing an equation in standard form. Here we go. So we're going to set this up. 80 equals 8 times X plus 4 times Y. Now this is it. This is as far as you can go. Why? Because you have two separate variables. You cannot solve this equation for a number unless you provide a value for X or Y. Okay, this is why standard form gets used for systems of equations. Like I said, I wanted to introduce you guys to that concept. Just start wrapping your brain around this. And then the last thing that I want to talk about before we're done with this video, I think we'll do one more problem, but I want to compare a problem in standard form to a problem in slope-intercept form. So let's open up another page and give this a try. So we've got y equals mx or ax plus b. Okay? So our slope is always mixed. X means, what are all those problems that we did? X was hours. X was years. X was number of basketballs for another one of our problems, right? What kind of things were Y? Y was things like gallons, feet of a tree, height. okay? Total cost. And the units for these were also, they were different. The slopes were blended. The units were blended. It was gallons per hour, feet per year, cost per basketball. Okay? So when you have a situation where you are comparing two quantities that are completely different, this is when you're going to use slope-intercept, form of a line. When you are comparing two quantities that are the same, they're different things, but they're measured in the same exact units. 8 feet, 4 feet, large birdhouse, small birdhouse. That's standard form. Let's do another one before we're done. And here's the answer to problem 5. We did it right. So here's Taylor. He can finish a small jigsaw puzzle in 5 hours and a large jigsaw puzzle in 12. So what they're asking is for us to write a linear equation that models the possible amounts of small jigsaw puzzles, X. So small puzzles are X, and large puzzles are Y. Okay? So what are our units? So they're telling us that he has a total of 120 hours. So we know that's on one side of the equation. So we have our small puzzles, X. So he can do a small one in 5 hours. All right, that's 5X. And he can do a large one in 12 hours. So when you add these two things together, you get a total number of hours. So here we go. We have hours, we have hours, and we have hours. Okay? The question that's being asked is different than we do when we're looking at a slope-intercept problem. Okay? And then last but not least, you cannot answer a problem written in standard form unless you have a way to get rid of one of the variables. These two variables are equal. One does not depend upon the other. Okay? So thank you guys very much for listening. I hope this was helpful, and we'll keep doing more of these.